Welcome back everyone. I'm sorry it had been a long time since we had our lecture. The situation is beyond our control, but by August 10th, we shall be back in full time. Before we begin, let my partner introduce himself.
My name is Meister Teacher. Thank you for having me.
I'm happy we had time to come out today to study. We shall be looking into immunochemistry. Have you ever wondered how you get well without taking drugs after falling sick? There are solids in your body that is responsible for handling foreign materials that comes in. We'll take time to explore them. However, we won't be able to finish in this video.
What is immunology? Immunology is the study of how our body fights against diseases and infections. History of immunology: 1796, Edward Jenner discovered that cowpox, a mild disease, can protect against smallpox, a deadly disease. 1979, the World Health Organization (WHO) announced that smallpox was eradicated, thanks to immunization. How does the immune system work? 1. Physical barriers. The immune system uses physical barriers like skin and mucous membranes to prevent pathogens, germs from entering the body. 2. Alerting the immune cells. If a pathogen enters the body, the immune system sends signals to alert the immune cells, like soldiers, to fight against the invader. 3. Fighting the infection. The immune cells work together to eliminate the pathogen and protect the body. For illustration, imagine a fortress. The body is like a fortress with physical barriers, walls, to keep out invaders' pathogens. If an invader enters, the immune system sends out soldiers, immune cells, to fight and protect the fortress.
Key points to note as we move on are: immunology is the study of how our body fights against diseases and infections. Immunity is the body's ability to resist or fight against diseases and infections. The immune system uses physical barriers and immune cells to protect the body against pathogens.
The organs of the immune system found throughout the body and are referred to as lymphoid organs include the tonsils and adenoids, thymus, lymph nodes, lymphatic vessels, Peyer's patches, bone marrow, spleen, and appendix. These organs take part in the growth, development, and sending of lymphocytes to wherever the body's defense system is compromised. There are two classes of lymphocytes, B and T lymphocytes, and this classification is based on where they mature. B lymphocytes complete their maturation in the bone marrow, while the T lymphocytes migrate to the thymus, where they multiply and mature into cells that become immunocompetent. The T cells become educated in order to be able to distinguish self cells from non-self cells.
We are going to take more look into molecules that can elicit immune responses.
Antigens. Substances that can trigger an immune response. Can react with antibodies or T cell receptors. Immunogens. Substances that can cause an immune response. Can stimulate the production of antibodies or immune cells. Haptens. Small molecules that can't trigger an immune response alone. Need to be attached to a larger molecule carrier to stimulate an immune response. Example: nitrophenol. Antigenic determinants, epitopes. Small regions on an antigen that antibodies bind to. Only a small part of the antigen is recognized by the antibody. Think of it like a key antigen fitting into a lock antibody. Paratope, the region on the antibody that recognizes and binds to the epitope. Like the teeth of the lock that fit into the key. Imagine a lock and key. Antigen key has a unique shape that fits into the antibody lock. Only a small part of the key epitope fits into the lock paratope.
Before we continue, key points. Antigens trigger an immune response and react with antibodies or T cell receptors. Immunogens stimulate an immune response, while haptens need a carrier to do so. Antigenic determinants, epitopes, are small regions on antigens that antibodies bind to. Paratope is the region on the antibody that recognizes and binds to the epitope.
Biological molecules that bind to antigens, lipids, proteins, carbohydrates, sugars, nucleic acids. What's special about antibodies? Antibodies can bind to a wide range of biological molecules listed above. Unlike T cell receptors, which can only bind to peptides, short chains of amino acids. Epitopes in macromolecules. Macromolecules, large molecules, have multiple epitopes, regions that antibodies bind to. Some epitopes may be repeated, allowing multiple antibodies to bind. This is known as polyvalency or multivalency. Polyvalency occurs when an antigen has multiple identical epitopes. Common in polysaccharides, long chains of sugars. Nucleic acids, like DNA and RNA, aggregates of globular proteins, proteins that cluster together. Not typically found in single globular proteins. Imagine a bunch of keys. Macromolecules have multiple epitopes, keys, that antibodies can bind to. Polyvalency is like having multiple identical keys that can fit into the same lock antibody.
Key points. Antibodies can bind to a wide range of biological molecules, Macromolecules have multiple epitopes, some of which may be repeated. Polyvalency occurs when an antigen has multiple identical epitopes, commonly found in polysaccharides, nucleic acids, and protein aggregates. Thank you for joining us.